Hello, my name is Alicia Sofia. In this video, my group mates Nurul Iman, Sushmita Subramaniam, and Akwin Kaur, and I will be presenting our project. We are from G1-4. Our project theme is based on aquaculture, and the title of our project is Automatic Fish Feeder. As the popularity of keeping fish as pets continue to grow, so does the need for reliable and convenient care solution. One of the biggest challenges aquarium owner face faces is maintaining consistent feeding schedule, especially when you are busy or away from home. This project focuses on designing an affordable, user-friendly, and reliable automatic fish feeder using microcontroller system. The goal is to automate the feeding process, prevent common issues like overfeeding or underfeeding, and enhance overall fish health. By integrating smart technologies, this project focuses on designing an affordable, user-friendly and reliable automatic fish feeder using microcontroller system. The goal is to automate the feeding process, prevent common issues like overfeeding or underfeeding, and enhance overall fish health. By integrating smart technology, this project aims to contribute to the growing field of smart pet care and offer a practical solution for modern aquarium owners.
Many aquarium owners face challenges of them have to feed fish consistently, and this arises when they are busy or away from home. And manual feeding methods are time consuming and can lead to overfeeding, which can pollute water, or underfeeding that can cause malnutrition to the fish. And existing automatic fish feeders are often expensive and complicated that usually leads to malfunction. And they struggle to maintain a regular feeding schedules. And so we need a simple automatic fish feeder which is more affordable, easy to use and reliable. This automatic fish feeder can able to feed the right amount of food and on time, and this can also maintain the water qualities.
Now let's take a look at the objective of our automated fish feeder. First and foremost, the goals are to ensure the fish are fed consistently at scheduled times. This means no more worrying about forgetting to feed them, and it is very helpful, especially if you are busy or not at home or you have a very hectic routine. Next, it is also designed to reduce reliance on pet owners. Our system helps prevent overfeeding, underfeeding, and missed meals by delivering accurate food portions every time. And finally, by delivering the right amount of food, we're also aiming to promote fish health, support growth, and aid digestions. Plus, we help reduce food waste and keep the water cleaner and all around win for your aquatic pets and for the environment.
This is a flowchart for our automatic fish feeder. So when you press the start button, users will set feeding schedule using mobile app website, and for our project, we use Blink app. And the schedule store in database and run in the program. And the microcontroller in the automatic fish feeder will be used to retrieve schedule using Arduino, Raspberry Pi. And then lastly, we have to check the current time. So if it's a feeding time, then the feeder motor will be activated. And if it's not feeding time, just wait and recheck. And when we activate the feeder motor, it will dispense fish food. And that's all.
So for the list of components, we have the first one. We used wooden panels, 2 pieces. So these were used as the base and the stand for the entire model, and they provided the stability and also they supported the model. Besides that, we have also bought an aquarium. So this is where the fish are kept and the main reason for the fish system to be built. And the third one is the plastic containers. So plastic containers are bought transparent ones because these containers can hold the fish food, and the transparency can allow the users to easily monitor the amount of food that is still available for each time. The fourth one is an hanging wall shelf. So this shelf is used to place the electrical components such as the microcontroller and also the motor systems, so it can keep them safe and also organized and it's not messed up. So the fifth one, we used a glue gun. So it was used to join different parts together, and it's a quick and also a strong way to assemble structures. And last but not least, we use iron brackets. So these were used to hold the plastics containers and the wall shelf in place. So they ensure the structure is already sturdy and it prevents components from falling. So for the electrical components, the first one we used was microcontroller, which was an Arduino Uno. So this was the heart of the system for the fish feeder because it controls the overall operations and also including the timing for the fish feeder and also the communications with other components. So the second one is a motor and feeder mechanism. We used a servo motor in this, whereby it rotates the feeding mechanism and it precisely controls the movement and also the dispensement of food towards the aquarium. The third one is power supply. So we used a battery pack to give battery and also power to the whole system. The fourth one is we use a sensor, which is optional, but we use still. So we include a real-time clock, RTC, and also this will allow the system to be accurate and scheduled in time. So the fifth one is storage and feeding container. So this includes a food hopper and a container to store fish food, along with dispenser mechanism. And the sixth one was software and IoT platform. So for remote control and automation, we use the platform and app called as Blink. And for the software, we used Arduino to code. And the seventh one is a user interface. So it's to make it user friendly, and we can develop more coding using the app, which is called Blink.
Here is the result. We are using wooden panel as a support for this project, and this is aquarium, and this is bottled water. This is the feeder, and there's holes under these holes, and this is the position of the servo motor. Servo motor will rotate the feeder whenever we want by using the website of Blink IoT. And this is we connect the ESP8266 to make it connect to the phone by using Wi-Fi. And this is how it looks like. So this is the app, which is I'm using Blink for the connection. Look like this. So this is it will rotate. So this is the position of when we don't want to feed the fish. So when we want to feed the fish, we rotate it back to, it will become like that, and the fish food will come out from this hole.
Maintaining a consistent and appropriate feeding schedule is essential for health, well-being, and also for the aquarium fish. So this project focuses on solving that problem by developing an automatic fish feeder controlled by a microcontroller. So manual feeding can be time-consuming, and it often leads to inconsistencies due to human error. And over time, this can actually negatively affect the aquatic environment in the aquarium and even shorter the lifespan of a fish. So our system is designed to be user-friendly programmable and also affordable. It allows users to schedule feeding times for the fishes in the aquarium and control the amount of food that can be given to each fish. So this will help prevent common issues like overfeeding or maybe underfeeding the fishes. So by using the smart technology, this feeder can simplify pet care and also promotes healthier living conditions for the fishes. So overall, it offers a modern and also a practical approach to aquarium feeding, making the hobby easier to be handled and also more enjoyable for fish owners to have a fish as a pet.